All right, well, this is workbook page 46, problems 2 and 3. So on problems 2 and 3, you're required to find the original coordinates before you start. That's the only way to really solve these. This is not something you can typically just eyeball. So I want to find the original coordinates of this triangle. So I'm going to start here at the tip, and that is 0, 2. And I'll go to the right, and that is 2, negative 2. And to the left, and that will be negative 2, negative 2. All right, now I want to go ahead and find these after the dilation. Well, I need the scale factor, and I can find the scale factor right here. It's listed. It's saying 2 times all the x values and 2 times all the y values. So the scale factor is 2. You're simply going to multiply all the digits by 2. So 0, 4, 4, negative 4, and negative 4, negative 4. And then we can go ahead and graph that image. 0, 4 is going to be here. 4, negative 4, so 4 places to the right, 1, 2, 3, 4. 4 places down, 1, 2, 3, 4. And for the last one, start at the origin, 4 places left, 1, 2, 3, 4, and 4 places down, 1, 2, 3, 4. Connect the dots, and we have the new dilated figure. All right, number 3, same thing. I need to find the original coordinates. So I'm going to start here at this point, and I'm going to find the original coordinates. That is 6, 3. Next one, I'll go here. That'll be 6, 0. Lower left. That will be negative 6, negative 3. And upper left will be negative 6, 3. So I need to apply the scale factor. And the scale factor is listed right there. It's 2/3. So I'm just going to put 2/3 up here so that I know what I'm multiplying by. And I'll use that little quick way. 6 times the numerator, so 6 times 2 is 12, divided by the denominator. So 6 times 2 is 12, divided by 3 is 4. So my new coordinate is 4. 3 times 2 is 6, divided by 3 is 2. So there is my prime coordinate. And so I know all the 6's are going to turn into 4, so that's helpful. I don't have to do it every single time. A negative 6 will just simply be a negative 4. Negative 3, we know that 3's turn into 2's. So this will just be a negative 2. Negative 4, 2. And you could do each one of these one at a time. And you also have your calculator in class that does fractions. And I believe if you take your phone calculator and turn it sideways, it'll also do fractions. So now we need to graph the new coordinates. Since this was less than 1, we can expect this image to shrink. So 4, 2, start at the origin, 4 places to the right, 1, 2, 3, 4, 2 places up. All right, now 4, 0, so 4 places to the right, nothing up or down. Negative 4, negative 2, 4 places left, 1, 2, 3, 4, and 2 places down. And we can connect those. And negative 4, 2, 1, 2, 3, 4, 1, 2. And there is our dilated image. All right, let's go to problem number 4. All right, so on numbers 4 and 5, we are determining what the scale factor is. So what you need to do is you need to take one from the original. You need a straight side, either vertically or horizontal, either flat or straight up. You don't want to use diagonals because they can be misleading. Since I don't have anything that's completely vertical or horizontal, I'm going to take the distance between these 2 points right here. And that is, if you count, that's 1, 2, 3, 4. That is 4 units. And so the matching piece is right here, and it's 1 unit. And the way you set this up is you put the new over the original. And so we know that the new unit, it was just 1. And from the original, it was 4 units. You ask yourself, can this be simplified? This one cannot, so your answer of scale factor is 1/4. Number 5, I can take any side of this. Let's just take this side. 1, 2, 3, 4. So that's 4 units. And this is the corresponding side, and it's 2 units. So same thing, we do the new over the old. Now this one can be reduced. This is 1/2, and that is the scale factor. Always ask yourself, does it make sense? It went from big to small. That typically means you're multiplying by a fraction, and it has to be less than 1. This does satisfy that, so this is the correct answer. So your answer is 1/2.